Using ANSYS APDL, we need to solve this system of springs, that is K1, K2, K3, K4 and K5, all of them having 10 Newton per meter stiffness, and also we are going to apply force F1 equal to 50 Newton, F2 equal to minus 10 Newton and F3 equal to 75 Newton. This problem we are going to solve in ANSYS APDL. Okay, so first you have to open the file explorer and this ANSYS APDL program, and you have to run this. So go to preferences, select structural, OK. Then go to preprocessor, element type, add, edit, delete, add. Here we are going to select the element as link actuator 11, then OK. Close. For this particular problem we need only one type of element, that is link 11. Next step, we need to add the real constants. Click real constants and go to add, edit, delete, add, OK. So here we have 5 elements, but the thing is that all of them having same stiffness, that is 10 Newton per meter. So just enter the values 10, apply, then second element also 10, apply, third element 10, apply, fourth element 10, apply, fifth element 10, apply, OK. So you can see that set 1, set 2, set 3, set 4 and set 5, all the elements are added with 10 Newton per meter stiffness. So we can close this. So once again we will check our the question. Okay, so we have one spring K1 here, and second spring K2 here, third spring K3 connecting between element 1 and element node 2 and node 5. So here we have 1, 2, 3. These nodes are the same for same as node 2. Then node 1, node 2. These 3 nodes are node 2. Then this is node 3, and here the last one is node 4. So we have 4 nodes for this particular problem. So now we have assigned the element type and real constants. Now we can go for modeling. So here we are going to create nodes in active CS. Then similar way we need to create 4 nodes. So number 1 is 0, 0, 0, apply. The second node I will make at a distance. Okay, since there are 4 nodes, I will divide the unit, let us say 1 unit length, into 3 equal parts, so that we will get 4 nodes. So the second node will be 1 by 3, apply. The third node is 2 by 3, apply, and fourth node is 1, then OK. So here we have 1, 2, 3, 4 nodes. Now we will apply, now we will make the elements. So we can go to elements. First we will select the assign the element attribute to each element before making them. So go to element attributes. So here real constant set number. Here you can see all the 5 elements whichever we have added is appearing here. So we have to assign the set number 1 to the first link. Okay. Then go to auto numbered through nodes. Click 1 and 2. Then OK. So this is because this is the K1 element which is connecting between node 1 and 2. So now we will connect this second element K2, that is from node 2 to node 3. Okay. So go to again element attributes, define the second set, okay, through nodes, that is 2 to 3, then okay. Go to element attributes, change this to 3, okay. So third element is connecting between 2 and 4. You can see here third element, this is the third element which is connecting between 2 and 4. So through nodes 2 and 4, okay. Then again we will go to the element attributes. So here between this 3 and 4 we have 2 elements. So again through nodes 3 to 4, okay. Again element attributes, change to the fifth, okay, through nodes 3 and 4, okay. So we have most of the things we have done. Now the solving part. So you can go to loads, analysis type, new analysis, static, okay, define loads, settings, node setting, you can go to analysis, define loads, apply, structural, displacement, on nodes, pick the first node, okay. Then we are going to arrest all the degree of freedom, okay. Then force on nodes. So this force we have decided F1, that is here on the second node it is 50 Newton. On the F2 there is a load of minus 10 Newton, that is towards the left hand side, and F3 75 Newton. So click the second node, then OK, Fx and constant value 50, apply. Then third node, OK. So this is again Fx but minus 10, apply. Then on the fourth node, okay, then positive 75, okay. So we have given the displacement constraints and as well as force. Now we can solve to get the results. So go to solution, solve, current ls, okay. So solution is done, close. So go to general post process, list results, nodal solution, degree of freedom solution, x component of displacement, okay. So you can see that the results 11.5, 13.9 and 15.6. So on the node 2 there is a displacement of 11.5 millimeter, and on the node 3 it is 13.9, and at node 4 it is 15.6, and we have solved this problem. Thank you.